Hey guys, coming to you live from my kitchen since I didn't get the chance to do this at school while I was still there. So this is lesson 9, applying the properties of and operations to add and subtract rational numbers. So basically, you're combining, adding, and subtracting both fractions and decimals potentially in the same problem. And there's really no right or wrong way to go about solving this problem. So I'm going to kind of give you some freedom on how you approach it. So even though this classwork exercise 1 says to unscramble the cards and show the steps in the correct order, here's technically the correct order. This should go first, second, third, fourth, and fifth. But I want to show you that that's not the only way to solve this problem. So I'm actually going to do some of the work off to the side here and show you, another way that you could go about thinking about this problem, maybe without so many parentheses and things like that to kind of get you confused. So here's the original problem, 5 2/9 minus, and in parentheses it's 8.1 plus 5 2/9. So I know that you learned the distributive property in 6th grade, so I'm going to approach it from that angle. I'm going to pretend like there's a -1 here, and that I'm going to distribute that to each of these numbers on the inside. And when I do that, this 5 2/9 stays right where it is because nothing about that number changed. This becomes -8.1, and this becomes -5 2/9. So what I'm doing in my mind is I'm saying to myself, what is the opposite, because that's what this minus represents. What is the opposite of 8.1? Well, it's -8.1. What is the opposite of 5 2/9? It's -5 2/9. And so my next step I'm going to do is use the commutative property. But eventually what you're going to be able to do is not have to write this step down. This is a step that should be done in your head. You should recognize, without having to write it down, see how I covered that 8.1 there? You should recognize that we have 5 2/9 and -5 2/9 in the same problem. And because they're opposites, they're going to go to 0. You might hear other teachers say that they cancel each other out. So that's a common phrase that you'll hear. They just cancel each other out. And instead of writing down the work that I'm going to show you here in a second, they literally just cross them off in this step right here. They would put a line through this and a line through this, and they'd call it a day. So that's eventually where I want you to get to, but I want you to understand where that came from. So I'm going to rearrange this problem. That pen is dying on me. I'm going to rearrange this problem. That's the 5 2/9, that's right there. And then I'm going to bring this 5 2/9 next to it. And what do we know about 5 2/9 minus 5 2/9? Well, it's 0, right? And what is 0 minus 8.1? It is -8.1. Which is, if you look over here, the answer that we got. But I didn't have to write down so many steps. And in fact, the work for that will get even easier, like I said. So let me show you now what that would look like in an upper level class. They would say 5 2/9 minus 5 2/9 cancel each other out completely, and all I'm left with is -8.1. Boop, there's the answer. They would have gotten to skip this step and this step. The idea is to not have to write those down. Makes your life simpler. Okay. So the next example on page 50. Sorry, I had to find what page that was on. It says, represent each of the following expressions in one rational number. All it's asking you to do there is to solve this thing. I don't know why they give you such complicated directions for literally solving, but it is what it is, and let's do it. So I'm going to approach this problem the same way I did the last one because I noticed the parentheses and I noticed the negative in front of it. So I'm thinking to myself, negative means opposite. So what is the opposite of 4 4/7? -4 4/7. What's the opposite of negative 10? Positive 10. So I'm going to rewrite this problem. 4 4/7, that's that guy right there, minus 4 4/7, because that's the opposite, plus 10, because that's the opposite. So hopefully you notice that 4 4/7 and negative 4 4/7 is 0. And then our final answer is 10. Again, in your upper level class, you wouldn't even have to write that line down. You would cancel this, cancel this, cancel this, call it 10. Number 2, 5 plus negative 4 4/7. So this, obviously, there is no distributive property here because these parentheses are just acting as a separator between your positive and negative sign. So I don't have to think about this one in terms of distributive property. I just have to actually add them up and see what I get. So 4 4/7. Like in the last lesson, you're going to want to think about 5 now as the number 4 and 7/7. So 4 and 7/7, if I add them together, I still get 5. It's just like I took a piece of the 5's whole and turned it into its fraction. So now I have 4 minus 4, and I have 7/7 minus 4/7. Kind of think about them like this, like they're their own separate problems. Deal with your whole numbers and your fractions separately. So 4 minus 4 is nothing. So I have no whole number anymore. There's a 0 here. I'm not really going to write 0 in my answer, but there's nothing left in the whole part. 7/7 minus 4/7. 7 minus 4 is 3/7. So my final answer, now I just have to, before I write my final answer down, look at which one of these was the bigger absolute value and 5 was. So my answer will be positive 3/7. Now I'm done. Okay, so your job is to go try, this is on page 51, go try these 4 problems and see what you come up with. I'm going to tell you in advance that it's okay to either turn decimals into fractions or fractions into decimals to make them easier to work with. That's absolutely okay. And in fact, I encourage you to do that, especially when you get to problem like C or D. Okay?